Cloudfather here. Today we're going to explore some laser stuff. The first thing we're taking a look at is the gantry. As you can see, you've got two rails on the X, which in the video are basically going on both sides of the enclosure. Then you have the X-axis, which goes across the enclosure. There are three sets of wheels on each axis that hold the X bar on top of the Y bars. Up in the corner, there's an adjustment for adjusting belt tension. In the center, you can see the laser mount and the cables that go into the laser itself. You can see the cable management system, the air hose, and so forth. We're now going to clean the laser. So on this one, we only have two screws to remove to clean the bottom. That's consistent with the original skirt. So we'll pull those out. And there we have it. Now, notice all of the burn marks. This is 6mm cast acrylic, and the orange stuff is safety acrylic, the same stuff we use for our cabinet here, or our enclosure. You'll notice on the back side it's pretty clean. And what's really is important is as we look down here into the laser, notice there's no scorch marks in the heatsink. Everything is clean underneath there. The focuser you can see burn marks on, and that's because right below the laser, when the flame ball reflects back to the cone, it's basically 3,000 to 5,000 degrees. So it gets very warm here. And if you leave these uncovered and you don't have a filter or a blast shield, It literally burns the fronts off the heat sinks and overheats all the electronics. So the next piece is we're going to take the filter out of the main module, and all we have to do is just take our finger and slide it right through. And you notice that the inside of here is pretty clean. Normally after 6 to 8 hours, it's going to look much worse than this. Between the top and bottom filters and the fact that the blast shield also deflects exhaust out the side rather than down and right back up again where the fan sucks it back in. Between all of those and different types of filters, of which we use 3 different types, this helps keep the laser much cooler, and it's going to run a lot longer. Now, normally we don't take the fan out except for maybe once every 2 or 3 weeks. With the current filter design, depending on how dirty we're going, we can get it filthy and it will still basically keep stuff out of the enclosure of the laser head for about 6 to 10 days under very heavy use. We're talking 8 to 10 hours a day of lasing. And normally this laser, which is a 70 watt, because we're doing mostly engraving, it primarily gets used in the 35 watt mode. The 35 watt mode has an advantage in the fact that only half the diodes come on, so the size of the beam is 1/2 of when you have all the diodes on in 70 watt mode. So these screws that I'm unscrewing are the original screws that hold the fan in, and what we're doing is we're taking this off so we can show you how the fan is situated and what you have to be careful with. And then we're going to blow out all the dust. It's been about 11 days since this was last taken apart and cleaned up. And there's a couple of ways to do this. You can actually just take the 4 screws out of the side, but we wanted to show you 2 different ways to do it. In this particular case, I'm taking the fan out of the fan mounting plate that's part of the laser so that we can clean the inside of the fan easier. You know, if I've only gone a week or so, I usually just blow with a vacuum cleaner in reverse, and that will take about 85% of the crud out. These are long screws, they have a lot of threads, so it takes a minute. And these screws are actually threaded into the fan itself, which is why it's hard to find a replacement fan. If you order a replacement fan from someone other than Atom Stack, it won't have the captive nuts molded in the fan. And it will make it a lot more interesting to try to bolt it into the standard fan housing. They also have to be the right current, the right voltage, and the right cubic feet per minute. The stock fan in the 70 here is 44 to 54 cubic feet a minute, and those are hard to find. They draw a 1/2 amp. So if you're looking for fans, you're looking for a 60 by 60 by 25. That's the physical size of it. Has to be a 2-wire fan, not a 3 or a 4-wire fan. It's got to be 24 volts at 500 milliamps or 1/2 amp. Anything else that doesn't have those specs is simply going to put your laser at risk. Either the fan doesn't have enough pressure, doesn't go fast enough, you know, low current fan, they all look the same. You can get anywhere from 150 milliamps, maybe even 100, up to 500. And the 500 ones are not cheap, but it's because they push a considerably more air pressure through the heatsink assembly than other fans do. And you cannot use a 40-watt fan, a 40-watt laser fan in a 70-watt laser. It's got to be a fan that's 500 milliamps. They look the same, but if you look at the current on the 40, it's 250 mils. It's kind of like horsepower for your car. Okay, so there's the assembly that holds the filter material on the fan. Now you basically have a stock laser here. What we're going to do next is take these little side screws out, and those you have to be careful of. And the other thing you got to be careful of is there's a bunch of little shims that fit underneath the fan, and that's something that comes apart and gets loose inside the laser head when you take it apart. You want to use a fine screwdriver like these jeweler screwdrivers. And be very careful of these screws. They're guaranteed to strip out after a while. I will eventually replace them with the M3 screws. These are M1s. And the problem is the threads are very fine. It's difficult to get them in. So if the hole gets drilled out, it'll make it easier to service the laser. Magnetic screwdrivers are a big help. Okay, now we can see the inside of the laser. This is the data and control connector. This is the variable voltage to the laser that determines the maximum power. And then this is your negative terminal and your plus 36 terminal. This is your air tube for the bottom. So now we're going to let the fan out here. And when we let the fan out, you're going to find 4 of these little black spacers. And if you're smart, you remember to super glue them on so they don't fall out. So now, here is the laser, the all-important connector. Remember, the red side of the cable goes to the inside of the laser, the black goes to the outside. And notice that the fan has directions. You'll notice I have arrows on here. So the fan normally blows air like this. So the label goes towards the heatsink. So it'll mount in like that. And that's extremely important. Now notice how clean the fan blades are. And the fan still spins freely. And this is after 11 days of use, working about 8 to 12 hours a day. Normally, in a laser that doesn't have the filters, you get about 8 hours. In fact, if you're doing plywood, you get maybe 4 to 6. And you'll notice that the inside here, the heatsink assembly, is still very clean. You can take your finger and wipe it in there, and basically your finger will be clean when it comes out. This is where the really important place to keep clean is. So now we're going to fire up the vacuum cleaner, and there's going to be some noise, but we're going to go through and blow all the dust out. We put these out of the way here so we don't lose all our little screws and things. Helps to have a bottle cap or something to keep your stuff together. Paint can lid works actually really good for that. So now we'll put our ear protection on here, and we'll use the vacuum cleaner in blow mode. So now you want to blow the laser from the top like this. You want to hold the fan blade while you clean it. And then you go the other direction. So normally to clean, we use this type of stick, and we'll use acetone. That's a lens cleaner. But first we're going to go over the fan a bit. And this one's clean. Notice I'm rubbing here, and it's got a little bit of film on it, but not a lot. And you have to do both sides. And you got to make sure that the outer walls of the fan shroud are clean as well. And it's important because if they get dirty, it slows the fan down and it might even stick. If it does, your laser will instantly overheat. It'll destroy it. So now we flip it over. We'll go through the back side. Just take your time. And you have to get both sides of the shroud. Okay, so the fan is clean. Now we're going to put it back in. So first thing we need to remember is, where's the airflow? It's going this way, here's the arrow. Now the fan normally sits in here like this. But you have to be careful to get the wires in. So the wire should go in right there. So now the fun part. There should be 4 of these. So we're going to wipe down the fan holder assembly, and then we're going to super glue those guys back in. And then we lift it up and check, make sure the holes are aligned so the screws will go in nicely. Okay, so we're going to let that dry for about 10 minutes. Okay, the fan filter housing is now on top of the laser. We put the screws back in. Fan actually we take the fan and put it in first, and then we put these 4 screws in. So pretty simple. The next piece is we're going to take the dovetail off. And I take this off to just clean the little lever here. So it comes off like that. And this little switch right here is the biggest weakness of this laser. That's a very flimsy little switch. So you have 4 mounting screws. And notice I have this washer up here. The washer tilts the laser head 7.5 degrees, and that way the backflash doesn't come back in the nose. So what we have to look at is this little assembly. Notice how dirty that is. It was just cleaned a week ago. And so you want to make sure that it freely moves. And then what you have to do is make sure that this end just touches that little switch. So you slide it this way, and then you start putting your screws in. And you want to just barely screw them in so you got a little wiggle room to adjust things. And you can tell, you can see it comes back. That's what you're looking for. If it doesn't do that, it's misaligned, and that will damage that very flimsy switch. On the ones up here in the other end, where the shim is, they're going to turn about a turn. And that's enough to keep them in there. Then we come back here and snug these guys just a little, using very little pressure. And now our switch has been serviced. So the next part is we're going to take the cone off. This is the cone assembly, and it has 2 parts. So we'll go through and take them all apart. Normally I just take the bottom off. So this has a fine pitch thread, so you got to be careful to keep it clean and to take your time with it. You don't want to be burring this up. So you can see the end of the nozzle where the back glass previously had marred this. You can see all the crud on here. It's not all that important to keep it clean, but you can see the buildup. Now, if you look in the hole, you probably can't see in the camera, but that's your output lens. So I'm going to put the nozzle back in the output lens assembly. Then I have a little hex wrench I use to loosen the nut over here. And there's a little slot right here. So you can either do it this way if you have one that's bent, or you can take a longer key. It just takes about a quarter of a turn. Just wiggle it. And this is the whole assembly. You want to look inside, make sure there's no debris in there. They don't generally collect it. But the laser, this is the part you got to keep clean. And it probably won't show on here, but you can barely see just a little tracing of dust on there. So we're taking a clean Q-tip, dipping it in acetone. We just do a gentle wiping motion. And if you see any crud around anywhere else, make sure you clean that off. These are soft, non-treated raw cotton swabs. Then you have a dry one, which you do your final pass. And what you want to do is look at this sideways in the light so you can see the reflection. And by the way, if you have to take these out, this just unscrews and you put the new lens in. You have to make sure that the amber mirror side is facing this way, towards the workpiece. Now this one's clean. There's not a smudge, a mark, or anything. And that's gone through 10 days. If you don't have the filters and the blast assembly, these can go in as little as 20, 30 hours. And then you have to replace them. But if you keep them clean, they'll last a very long time. Now, this little guy can be kind of a pain in the butt to get in there. Where it's going is out this other hole. And so if you do a look at it from the rear, once you get it that far, it'll slide right in. This guy just pushes down there. Then you get your key out. You're going to turn it about a quarter of a turn. And so now it's mounted on there. So now we're going to go put the blast shield back on. Now the blast shield has spacers which go in the holes opposite of where your skirt holes used to be. And you have to make sure that you get the mounting in the correct place. It's easy to get them mixed up, and I did on this. Let me get that fixed here. Okay, so this is what it should look like. The filter for the flame detector should be to the inside. These should be here. So we put the spacers on. Notice the notch where the dovetail is. That's so you can get the filter paper underneath it. Okay, so now if you have it correctly installed, you have the little bumpers. We put the bottom filter piece on. Those are what allow it to stick to the outside. They just sit around the outside. So now you'll notice you have your IR sensor and your alignment light. And then you have your blast detector around the cone. Okay, for the next part, we're going to take this blue film. This is 3M hospital vent filter. And we're going to cut ourselves a couple of squares. And where they're going is they're going to fit in here. This filter material I like because it's sticky, so it catches stuff. And then we have one other type of filter. This is a Filtrete filter. It's used for the intake of air conditioners. So we cut ourselves a little square of that. And your goal is basically to put this over the round hole. It becomes the final piece of material that is keeping the dust out of the laser. So basically it's just going to sit in here, and you can trim it in the corners. Makes it a little easier to hold in there. So all right, if it overhangs, you can be as pretty or as lazy as you want, and the filter will still work the same. This is the bottom filter, so it's going to sit right here, and we have enough room to get our cables in. Then the largest of the blue pieces goes in first, and usually I cut the corners of this off too. It makes it easier. You don't need to take a lot off. The other thing that works good are lawnmower air filters. So you keep your finger on here, you work your blue piece in. Your goal is to keep this white piece flattened out. So it's like that. And what you're looking to do is keep the filter even across the bottom. This top piece basically just holds it all in there. The other stuff I use is actually filters from lawnmowers. The air filters that Briggs & Stratton makes, the yellow foam, if you can find a big enough piece of it, is the best filter material I've used. The blue foam works well, but the other is the best, no question. But this stuff does work, and I'm getting 10, 12 days out. So now you've got the final filter, the mid filter. Now we're going to basically measure a piece that's going to go around like this, which forms our outer filter. You can just use the whole piece. I usually cut them down though, just for grins. So I cut a piece that is going to be right about here. And again, this is just like the outer filter on your lawnmower or your high-performance Corvette. It catches the grossest of the stuff, and it catches the hot, sticky gases coming up. So this piece we're going to hold on to. After we put it on after we put the laser in. Now we're going to do the bottom filter with what's left. So I'll put it on its nose here. And what I do is I stick it down in a little notch above the focuser, like that. Now all we have to do is just fold it around. Now a piece of tape, or in my case I use tie wraps, is all that's needed to hold this on. Rubber band works just as good. The advantage of the rubber band, though, is that it gets underneath the, it's kind of tight right in the center section there. So I usually take a rubber band and just work it in like this. And then we just fold it around. So you just keep pulling and stretching. It takes a minute to get it all stretched out, but once it's stretched out, it will overlap. And that's basically all you have to do. This is basically going to catch 99% of shit that might flow up. And remember, you have the blast shield. So the blast shield is pushing everything about 400 millimeters in all four directions, so there's very little. This is all high pressure air coming out, and the high pressure air is what's actually blowing all the debris, because normally if you don't have this stuff on, the laser blows it out, hits the work surface, it gets hot, and it immediately gets sucked up into the fan, and you just keep coating. And this is what's killing the fans and the lasers. So now it's ready to go back into the system. So this is your laser head, and you notice this one has a blast shield on it. And for those that don't believe that blast shields aren't important, notice how burned up everything is right here. What's happening is this laser is tilted at 7.5 degrees instead of being perpendicular. And you can see that the laser is hitting over here and it's not hitting the cone. If you don't have a shim in your laser, it's going right back up the cone, destroying your output lens and then destroying your laser. So that's the reason why we have those on there. What we see right here, this is the focusing sensor. So it goes down, touches that, then it goes back up the top, and it usually makes two passes. What we have in the bottom of this one is this is a filter for the bottom of the laser, which actually gets dirtier than the top. Here is the dovetail. Up in top, we have a top filter. And so the top filter has three different types of filter material. There's an outer filter that covers this. And then we have a white filter and a blue filter, and they all grab different sizes of particles. So this is something that you can build for your laser if you want your laser to have filters. Okay. So laser data connector, laser power connector, air. So I have taken the set screws out and I use the same thread pattern. This is an an M3 screw, because it's easier for me to deal with this when I'm bent over in a cabinet. So we're going to take the laser, slide it back down, and it typically fits about here. The nice thing about these is you can finger tighten them while you're getting the rest of the stuff together. Now the next battle is kind of hard to see from that angle, but what I'm doing is plugging the cables back in.